Well, this is week 2, our lesson 2. We are going to cover Math Fluency Books chapter 3, which are going to be divisibility and prime numbers. Definition of the prime number, right? A whole number greater than 1 with exactly 2 factors, 1 and itself. But the interesting thing is what? 2 is the only even prime number, right?
Yeah.
So if the prime number is if a whole number is greater than 1 with more than 2 factors, it's called a composite number. 20 is obviously a composite number, right? 20. What about 29?
29 is prime. I know it's not prime.
What about 121?
20 is not prime. 21 isn't there. Prime.
It's not prime, right? 121.
No, not 21. Oh, yeah,
It's a perfect square, right?
Mhm.
Why? Because 11 times 11. 91. I put 91 because I had a very interesting history about 91. When I was in middle school, I was thinking 91 is a prime number. But it's not prime, right? Why?
Because you can do it by 20.
91 is interesting number. Now, what times what gives you? There's a 2 prime factors of 91. One is 7, the other one is 7 times what?
13.
7 times 13, yes. That's that's not a prime number. So here is the very interesting sieve of some very famous mathematicians. It's hard to say. How we can discover first few, I will say 25 prime numbers until 100. I said 25 prime numbers until 100? Yes.
There should be 26.
Are you sure?
Sorry, wait. 8, 10.
25.
Yeah.
Where do you get the extra 26? I mean, the extra one.
Yes.
Yeah, I got 25.
25.
I got 25.
Somehow.
Yeah, it's remember you can remember one only single one is 90s and only first two for 4 and then 25% off. That's good to remember. Okay, great. Then what do we know about the prime factorization? I think this one is 4th grade, 5th grade stuff. The teacher are right showing you how you make it. It's called a prime factor 3 or other things. So let's say how can you make it 60? You can do this way. 60 divided by 2. 30. 30 divided by 2.
15.
15 divided by what?
3 equals 5.
And 5. Then how you write this one? 2 times 3 times 5, which is 2 square, 3 and 5, right? You can do that way. Or you can do just other method. Or you can, when you have a good number sense, you can do this way directly. 60 is what? 4 times 15, right? Therefore, 2 square times 3 times 5. That's why we would like you to have a good number sense. Being a good number sense means you do some mental math and you can do easily those prime factorization. That means avoid hard work, be smart. Okay, let's keep going. As you see that the next topics, the next concept is perfect square and perfect cube. So what do you see here? I think you are supposed to know until 15 square. It's good to know. So do you see that? I can see here 14 square and 14 square is this is interesting. There is a mistake here. The mistake is here. This is 13 square. 15 square. I skipped the 14 square. What's the 14 square? One, because I remember this guy. Because what do you notice? 13 square and 14 square. 13 square is 169. 14 square is 196, right?
Right.
You can remember that one. 15 square is 225. Okay, what about cube? It's good to know until 10 cube. So these guys, you can remember 7 cube is 7 times 7 times 7 times 7, which is, and then 8 cube is also, 8 cube is also 2 to the power of what? 2 to the power of 6, right? Or 2 to the power of 8.
Yes.
2 cube, 2 to the power of 9. Sorry, 2 to the power of 9. So that's okay. Then 9 cube is 729. So here's my question. So when you can see that on the green one is perfect cubes until 15, and so perfect square until 15, and then perfect cubes until 10. So here's my question. Can you find a number both perfect square and perfect cube? Yes, go ahead and think about it. If you find one, tell me. Yes.
64.
64, consider perfect cube. Why? Or perfect square first. 8 square and perfect cube of what? 4 cube. Can you see another?
1.
Yes, 1. Of course, you're right. 1 cube and 1 square. I think that's the only one, right? Until this time. Okay, good. So that's good to know. Okay. So perfect cube. Now we are going to go over now divisibility rule, because we are going to these divisibility rule are very important for us to really operate a lot of interesting problem number theory the problems. So as you know, divisible rule by 2, it's easy, right? The last number is what? 0, 2, 4, 6, 8, right? Even. Okay, divisibility rule by 5 and by 10. These are the easiest one, right? 2, 5, and 10. Then after, which one coming? 3 and 9. What is special for 3 and 9? You add.
It's divisible by 3.
Yes. Do you see that 1002? 1002. How you check whether this number
Divisible by 9 and 3.
Mhm.
Oh no, sorry.
No,
It's
no.
it's divisible by 3, but not 9.
not 9? That's good. What about this guy? 14,238.
It's divisible by 3 and 9.
Why? Because 1 plus 4 plus 2 plus 3 plus 8, it should be what? 9, 18, right?
9, 7, 8.
That is going to be multiple. It's a good. Okay, that's good. We got that one. Also, there is a connection between 4 and 8. Maybe next year I'm going to explain with this one the reasoning. What's the reason behind? It's good to see that reason behind this rule. When you learn a little bit algebra, and I will explain better why this rule works. It's very nice because it's when you divide it by 3, let's say if you have 1000, ABC means what? ABC means 100A plus 10B plus C, right? When you divide it by 3 or 9, it's just leftover remainder A, remainder B, remainder C, right? Do you see that you got some sense, right?
Mhm.
That's why it's always we look for the A, B, C sum. It doesn't matter what number, or because multiples of 10, multiples of 100, it's just remainder of A, B, C. That's why we look for the sum of the numbers, digits. We look for last two digits, right? If it is, let's say The first one is 28. It's divisible by 4, right? And then
Yeah.
also divisible by 8. Why? It's most
That's-
likely 128. Last 3, right?
Above 8.
Okay. Then therefore, and divisible by 6 is going to be 2 and 3. What about divisible by 12?
You could do that with 4.
3 and 4, right?
Mm-hmm.
We check 3 and 4. Divisible by 15, we check 5 and 3. Okay, great. That is good. Now we can look at very interesting problem or some of the selected problems from your book. So this is the one of your problems that we are going to do together. Jamal, could you read the problem, please?
5m6 is a 3-digit number where m is a digit. If 5m6 is divisible by 3, find the sum of all the possible values of m.
Okay, let's think about it. That's thinking time. Okay, yeah, we were discussing about this. Then you said we are adding them together. So how does adding the digits help us?
It would help us like better visualize it and like not really long. We would make it smaller so we can understand better.
So what is divisible to rule by 3?
It's divisible by
3. So
Or-
we add what was the rule?
the rule was to like you need another digit that can divide that can be
Add the digit,
number,
right? Add the digit. This has to be what? Multiples of
3. That has to be equal 3 to like
So then 11 plus m. How can you get the multiples of 3? This could be 12, right?
Yeah,
This
but
could be 15. This could be 18. This could be 21, right? Let's see. If it is 12, m is equal to what?
2,
1.
3. No, it would be 3.
1, right? 3 doesn't work, right?
One because you can like keep adding 1 to get these different.
Yes. 1, then 4, then 7, 10.
What about 10? 10 does work. But 10 is not digit, right?
Yeah, that's 2 digits.
10 is not. Therefore, only what number?
7, 1, 4, 7.
Therefore, we have to also be careful about what is the question is asking us, right? Possible values of m. 1 plus 4 plus 7 is going to be what?
12.
The answer is
12.
12. That's great. So, yeah, we got it. So, let's keep.
Oh, can you go back to the question, please?
Yes.
Hold on.
So 1, 4, and 7, not 10. Then you add them together, and then we find. So we are going to do 3 similar problems, but using the different divisibility rules. So it's a good application problems. So do you see that we are doing a little bit better, cognitively better problems because we are not. I am not giving a number asking this is divisible by something. We are doing a little bit challenging problem. The next challenging problem is going to be divisible by 4. So there's a huge number, and I am asking that this is divisible by 4. First rule is divisible by, and a minimum value is we need to minimize the a and b. First of all, we look for the last 2 digits, right? 6 and b. This has to be what? 6b has to be?
Multiples of 4.
4. So what values what values can b get?
You can get 10, 14, 18, 20, 24, 28.
No, but 60 could be 60, right?
Yeah, it could be 60, yes.
This is not a plus. This is just the last 2 number as a 2-digit number. It could be 60. It could
60,
be
yes.
4.
This
It
is
could
not
be
off.
8, right? 60.
68. But yeah, that's it.
But what we like to have the minimum possible value, right? We have to minimize. We are not looking for the maximum, right?
Mm-hmm.
Do you think
Minimize is 0.
yes, the minimum value, right?
Remember the multiples are 0.
Yeah, it both could be 0 and 0, right? Therefore, the 0. What about maximum value?
The maximum value is 8.
Maximum A and B.
Oh.
Yeah, A could be anything, right? A could be anything. A could be what?
Could be
9.
like
B
10.
could be 8, right?
Mm-hmm.
Then therefore the maximum value would be 17, right? Good problem solving. That's nice. Good job. Well, let's do another interesting one. Divisibility problem of what? Yahya, could you read the question number 2, please?
Okay. For the digit 5T9 to divisible by 9, the sum of the digits must also be divisible by 9. Of the digits also to like I dot E dot 5 plus T plus 9 equal T plus 14 must be divisible by 9. Since
yes.
So I mean, since 0, like this thing, T, another that thing, 9, the only possible value of T is 4.
Okay.
Also, A plus 2 equal T, which means A plus 2 equal 4. Therefore, A equals 2. The sum of A plus T equal 2 plus 4 equals 6.
Are you reading or are you which one are
Oh,
you
yeah, I guess it works that way. Oh, wait, problem 3-4?
Oh, okay, I see. That's fine, no problem.
Oh,
Okay.
wait, was it a problem?
No, let's take a look at this problem. I will that's okay.
Okay.
So this is
The same problem.
yes, this problem. I don't know. I picked this problem from your book, but let's solve this one.
But isn't this the same one?
Wait, we can do like the problem 3-4. The sum of 3.
No.
Okay.
The first one, the one you just did,
Yes.
that's the same thing as this.
Yeah,
I
yeah, yeah.
think this is from your book, but I don't know what page.
But this is multiple of 20. This one says multiple of
Yeah, okay, let's take a look at this one. Multiples of 20. Okay, ready? So if this is multiples of 20, then what are we looking for? Divisibility rule by 4 and 5, right? Okay. Okay, let's take a look at and pause and think about this one. So let us go ahead. Let's start from the where should we start? How should we start from this solution?
First, we should be starting by taking the value of b, which can either be 5 or 0 because it needs to be a multiple of 20, or 5, which is 5 or 0.
That's a good starting.
Yes.
And what about looking at the divisible by 4?
The divisible by 4, we can take any multiples of 4, exampling
6,
0, 4,
and
and 8.
This is not working, right?
No.
Then you have to keep the 0 to last number, right?
Yes.
Therefore, the minimum value would be minimum A plus B would be 0 plus 0 again, right?
Yes.
What about maximum?
The maximum can be, the A value could be the maximum, could be 9, and the B maximum could be 5.
But if it is 5, is it divisible by 4?
No.
No.
So,
Therefore, we have to keep the last number 0, right?
yes.
The minimum value is 0, minimum sum is 0, and the maximum is 9. Okay.
Yes.
Great. Well, now let's take a look at another interesting one. The 4-digit number is divisible by 3, 4, and 5. So we are going to understand the sum of the all possible x values. So again, where's the good starting point? Yeah, 5, right? What's the possible value for last number?
For the least?
It's not least possible. Oh,
Okay.
5,
Possible numbers
0,
are. Hold up. What the fuck
0
is
and
divisible? 0 and
5.
Yeah, but if we were to like go further, it would be like 6, 8, right?
But if we have to have the divisibility by 5, therefore the plus number has to be what?
Has to be lower.
0 and 5. But we are not looking for maximum, we are looking for possible values, right? 0 and 5.
Oh, yeah.
Okay, now let's think about the 4. Can we have 5 at the end of this number, for this number? Because Jamal, why we cannot have 5? Why we should cross this one?
Because the 3.
Because 4
Oh, the 4.
divisible by 4, right? You cannot have 5 at the end, right? There is
No.
not there because x, it doesn't matter. Whatever you have, x is right. 15, 25, it's not going to be divisible by 4. Now we have only one option, but this option we have to check for what? By
4 by
divisibility rule by 3, right? Okay, let's add them together. 8 plus x has to be what? Divisible by multiples of 3, right? Then how many numbers are we going to have? Possible numbers. X is what? 1.
We could have 8 possible numbers.
But think about that one. I have to have 8 plus 1, right? 8 plus x has to be what? Multiple of what? 3. Because we are looking for the divisibility rule by 3. Then x is 1. What about 2? No, right? What about 3? No. X is 4. What is next? It always goes plus 3, right? 7. Because 7 plus 8 is 15. 7 plus 4 is 12. 8 plus 1 is 9. Then how many sum of all x values are going to be what? 1 plus 4 plus 7 is 12.
What am I doing?
Okay, great. So we are doing great. So let's see another interesting problem. Here, one more problem from the positive divisor. How many positive integer values of x, right? Because of that makes 60 over x an integer. How many? So how can we think about this one? Think of the positive divisor of 60. That means how many divisor of 60 do we have? Can we list them together? 1. What else? 2. What else?
3?
Yes. 4.
Yes.
It's all the way up to 60, right? Correct?
5.
Yes, 5. But
And
that's
then
going to, is
6.
going to be easy. 6.
Not 7. No.
What about 7? No. 8? No.
10.
10 in front of it.
10. Yes, good. What about 12?
11.
Because it's 3 and 3 and 4, therefore is 12, right?
What about like 20 or 30?
Yes. What about 15?
Yes.
Because
14 equals 60.
and then not 18, then 20, right?
Mm-hmm.
And then what's next?
30.
30. Good job. And finally,
60.
6. How many?
1.
How many total divisors?
Oh.
Well,
That means 12 numbers, 12 positive number make this one divide 60 evenly, right? That's the divide. That's called. So we will next week, maybe later, we will learn how there's a formula for number of divisor formula, number of divisor or number of factors formula. It's very nice formula, but this time we just list them together. So that's good. The final always we get confused. when I ask you, so here is the related to the final question. How many numbers between 10 and 20? 10 and 20 inclusive.
Like 12.
10 and 20.
11.
Ooh, 10 because sorry.
It's 11.
Why is 11?
Because if we count 10, 11, 12, 13, 14.
Yes. That's why this is interesting. If this is explain why the formula works for the if you start n1 blah 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 n2, the last number to include numbers of numbers is what? It's always that way. 20 minus 10 plus 1. Because the last number is always include, right? Okay, think about this one. Let's think about finally let's think about this one. Let's say you have 20 blah blah, it goes 21 and then 35. It's if you right, how many numbers do we have? Yes.
Wait, no,
How many
I'm
numbers do we have?
a different question. So
It's not 15, right? How many numbers? Number of numbers is
no,
35 minus what?
35 minus
20
20
plus
plus
1
wait, which question are you talking about?
is 16. We are just looking for this. There's a problem for explain why the formula n2 minus n1 plus
Is
1.
this in the book?
Yeah, there is a one problem for that.
Wait, is it like one of the questions or like
Yes, one of the question, yes. It's asking that number of numbers between two numbers, yeah.
13, 15?
Okay, yeah, pretty much this divisibility rule for this chapter and prime numbers, composite numbers, I think you should be okay for engaging all the chapters, set 1 and set 2. Chapter 3 for our book. It's going well, so we will be covering all the chapters together.